In episode 56 of Mobycast, we conclude our mini-series on how to become a great software developer. Welcome to Mobycast, a weekly conversation about cloud-native development, AWS, and building distributed systems. Let's jump right in.
Welcome, Chris and Rich. It's another episode of Mobycast.
Hey guys.
Good to have you back. So last week we were talking about these seven things to become a great software developer. And we, of course, as always, we like to make these long outlines for ourselves and prepare. And it's very difficult to have all of the important thoughts that we have, the very important thoughts that we have, and keep them to 20 or 30 minutes. So we got through 3 of the 7 things last week, and this week we'll do the other 4. We promise we'll get through all the other 4 this week. And the first 3 were practice, practice, practice. So always making sure to write actual code. Persistence, which is not giving up when things get challenging, and having the confidence that there is a solution to whatever problem you're facing, even if you need to ask for some help to push through those difficult parts and finish things. And then finally is number 3 last week was valuing understanding above correctness. So that was just really it boiled down to making sure you understand the code that you produce. And when you run into problems, don't spray and pray, or don't make random changes to your code, hoping to make the change that makes it work. Because if you're doing that, that probably means you don't understand the code that you wrote or the code that should be there. So taking the extra time to get that right and to understand it is going to pay off dividends for your future as a developer. So did you want to add anything to that summary of last week, Chris?
No, I think that's a great wrap up. The one thing that did kind of come to mind is like when we say that again, and like the whole idea of like spray and pray or making random tweaks kind of hoping something will work. That sounds a little crazy, right? Like, really, software developers do that? But the truth of the matter is, like, it's actually pretty common, which is kind of scary. So again, just reiterating, like, it's so important to not have that approach, but instead truly just it's a great opportunity to understand what's going on, stick with it, have that persistence, strive for the understanding. Don't be pressured into your velocity of getting work items done at the sake of compromising that understanding, because it's just going to pay off so much for you as you go forward.
Great. So yeah, as we said, we have 4 more to go. So what's the next one? I'm gonna not say them all in advance so that we can be surprised as each one comes. So what's the next one, Chris?
Funny, we had like Vanna White or something turning over numbers or whatnot. Yeah, so the next one to talk about would be go read code, analyze code, great code written by other people. Like, this is a great way to learn and improve, is by just studying the works of experts. And this is true for like so many industries, right? Like, artists do this, musicians do this, architects do this, all sorts of craftsmen have this kind of principle, right? So like, we as software developers, like, we should absolutely do this. So, and there's now with open source, it's so easy, right? It's so accessible to see these code bases and go and review them and get ideas and learn new techniques and see what it means to have elegant, concise, great code. So yeah, so go pick an open source project that you admire that's in your technology stack, and clone that repo and just start studying it. Look at it for things like, is there a consistent coding style? How readable is the code? How quickly can you understand, like, what is the software doing? What about documentation or tests? Like, are there tests included? Are they manual? Are they automated? I mean, these are all things that you can look at that kind of help define like what really great solid code looks like.
I think for any mid to senior developers listening, one of the fun things about doing this is that you'll go look at some code and of an open source project that you really admire or use a lot, and you'll be like, whoa, not all of this is that great. I can do as well as this. And that's just a really empowering feeling, right? Like, that's cool when that happens.
Absolutely. Yeah, absolutely. And it's a sign that you do have that. You've done some of the stuff that we've already talked about. You've done the practice and the persistence. And that helps you kind of identify like what's good code and what's not so great code, or like maybe you even think like, hey, there's a better way of doing this. Maybe you end up doing a pull request or something like that. Mm-hmm. So Absolutely.
Can you think of sorry to put you on the spot, but can you think of the last time you looked at an open source project, you looked at the code in detail and you're like, whew, this is so good?
I have to admit, I'm a pretty tough judge. I'm not easily impressed. And this is true, by the way, even with my own code. So it's like when I'm writing code, I'm usually thinking like, wow, this is like the best I've ever done. Like this is beautiful. Like this is great code. And then I'll come back to it like 6 months or a year later, and I'll be like, I'm not sure what I was thinking there. Like this could be better.
Right.
But I can't think of any particular open source project recently that I've looked at that I've been really impressed with. Honestly, I do look at a lot of software, a lot of open source software, but it's really kind of more a function of the fact that we use Node a lot in our projects, and so with Node has a great ecosystem of modules that you can pull in and use and whatnot. And so a lot of the times, just kind of understanding how things work or troubleshooting some stuff, sometimes the best documentation is the code itself. And so that's the kind of software I'm looking at. And a lot of times I'm kind of less than pleased with the code quality. I'm almost kind of sometimes surprised that like, wow, this I can't believe this works.
Right.
Type of thing. So it goes both ways, right? Like you can look at code that's really good and elegant, and you can use it as a way of improving learning. You can also look at code as a way of kind of identifying like, oh yeah, this could be done better, or this is like, I can identify some of the things that make it maybe not such a great piece of code, or maybe it's not maintainable or easy to understand. And those are valuable lessons that you can learn as well, right? It just reinforces those topics for you, and kind of gives you some of that empathy that you need when you are writing code, to keep that in mind. So it cuts both ways.
Right. I'll ask myself the same question because I was prepared. So the last time I saw code that I was like, ooh, pretty cool, was a library called PS PDF Kit. And I don't think it is not open source anymore. It was just the case that you could buy a source code license for it. And I was working for a client that had purchased that source code license. I don't even think you can buy a source code license anymore. But it's basically an iOS library for showing PDFs. And it really has become, if you need to do pretty sophisticated PDF stuff in your iOS mobile app, and I guess they probably support Android now too, but if you need to do that sophisticated PDF stuff, like drawing on top of a PDF or having multiple layers or searching through PDFs or all that kind of cool stuff that you might need to do, it really became the de facto, and Dropbox was using it, and so many other huge companies were using it. It was the best library. And I just remember looking at the code, and when I finally got my head around it, because it was fairly complicated, I was pretty impressed by how far the guy who had developed it was really a one-man shop at first, had pushed iOS. Like he really just wrung every last bit of everything he could, from everything from performance inside of iOS to memory management to just like what was possible with the UI. He had just wrung that out of iOS, and it was cool to read. So there are good examples out there, and it's fun to be impressed by a piece of code. So all right, so let's move on to the next one.
Yeah, moving on. So the kind of the fifth principle, if you will, is details matter, right? So I'm definitely a big believer in this, is that like dotting your I's, crossing your T's is really kind of important, especially when the software you're building has more of an audience than just yourself, which is almost always the case, right? So your software, the software that you're writing, it should be consistent. So all through your code base, it should have the same coding style, right? Like I don't care how many spaces you use, whether it's 2, 4, or 3.5. Just make sure that every single file has the same number of spaces. Same thing goes with tabs versus spaces. The way that you comment your code, if you have a common header or something like that in the files, like that should be very consistent throughout the code base. It should be organized, right? Like I should be able to look at the software, the way that it's structured, like from a directory standpoint, and it should be intuitive, like where I'm going to find stuff, like where's the config going to be, where would I expect database, the models to be, what about endpoint implementations, routes, and whatnot. Like all of that can be really easy for someone to figure out just by an organized directory structure that makes sense. Also just don't have software in your code base that's not being used. One of my biggest pet peeves is commenting out code. And why do it? This is why we have version control systems, right? Like if you want that code back, it's easy enough to get it. Let your version control system help you find that, right? So, but by commenting the code, it just gives someone, when someone's looking at that, they have to mentally process that and kind of understand, like, okay, maybe this is not important, but it's still there, right? So just get rid of it.
You have to answer the question, why is this not important? Whereas it's better just not to have that question in the first place.
Yes. Yeah. And then if you have dead code, like unused files, like get rid of them. Like there's just no reason to have it. So like there's nothing more satisfying like doing a commit when like the number of net new lines is negative. Like those are some of my happiest commits when I'm going through and refactoring and just kind of realizing like, hey, I just don't need this anymore, and just yanking it. I would love to have a program that was a single line long. That would be the best program, right?
So yeah, I think beyond those details are also just the details of making sure to think about what users actually do and thinking like a user, like thinking about who's using the software, what their expectations are, and if those expectations are being met, even in corner cases, and then actually trying those corner cases out and not just assuming that they work. I think that's part of thinking through details. And then another part of thinking through details is like reading, like if you have a UI and it's got words on it, just double checking that you spelled them right and that things are in the places that they're supposed to be and that they're the colors that they're supposed to be. Not doing those things is so expensive. Like having somebody else find those mistakes for you and then putting them into a system, and then you look in the system and then take the card and assign it to yourself and fix the 2-second bug and then put it all together in a pull request and have somebody else review that code. Like, oh my God, you just added 2 hours of work or 4 hours of work, who even knows, like a lot of work for different people just because you were too lazy to, make sure that you didn't spell guarantee wrong. Like, oh my God, just read it, proofread your stuff. That's obviously a pet peeve of mine, obviously.
Absolutely. Yeah. And I mean, these are the things too. Like it's pretty common for people to not do this or to place less emphasis on it. Right. But it really is important. Like being detailed at the end of the day, it kind of boils down to just really caring about like what you're doing and treating it as a craft and not as just a job or a task, right? So, and if you do that, like, and that's really what differentiates. That's one of the things that differentiates good from great. And just think about like a piece of furniture or a house. Details matter, right? Like the way that you did the joints on the piece of furniture. How much care and craft went into it, and how much attention was paid to the details. Like that makes a difference between a piece of furniture that's amazing versus one that's going to fall apart in 2 years.
Yeah, or even if it's sturdy, one that ends up in a landfill versus one that, is handed down from generation to generation for 500 years.
Mm-hmm. Absolutely. Yeah. So take that same approach with your software.
Yeah.
Hey there, this is Rich. Please pardon this quick interruption. We recently passed an internal milestone of 30,000 listens, and I wanted to take a moment to thank you for the support. I was also hoping to encourage you to head on over to iTunes to leave us a review. Positive feedback and constructive criticism are both incredibly important to us. So give us an idea of how we're doing, and we'll promise to keep publishing new episodes every week. Okay, let's dive back in.
Okay, what comes after details matter?
Yeah, so moving on. Next one, principle that really came to mind was just optimizing for clarity. So this is, again, another one of those things that you see quite often where people there's the tendency to prematurely optimize something. And we've all heard the expression, premature optimization is the root of all evil. But, you should really focus on making sure your code is readable and maintainable as opposed to being tricky or clever type thing, right? So, you may use like a very language specific idiom that allows you to combine the equivalent of like 4 lines of code on a single line of code. And you may be all proud of yourself and pat yourself on the back, but now anyone that looks at it's going to take them 20 minutes to figure out what's going on, right? Or to go look up some obscure part of the language reference to understand that. And at the end of the day, there's really no good reason for making people do that. Like, it didn't make a difference in the execution of the code necessarily.
So wait, Chris, you had just said that wouldn't it be awesome if you could write a program in one line of code?
Absolutely. As long as that one line was simple, concise, readable, and maintainable.
It does feel like there's just like a natural competition among developers to be more badass, like, and that like leaks into language idioms itself. Like, how dry can you make your code? How much can you pack into as few characters as possible? Look at this, it's only 13 lines, but it does like 1,700.
Yeah, absolutely. I mean, it is, and this is very much a tendency of developers to do this, right?
Mm-hmm.
And so that's why this kind of like came top of mind, is like, I would really love to see that not be the case. Like, instead, to have the badassery be in like taking pride in that when people see your code, they're like, oh my gosh, this is so easy to understand. Like, this is, I can jump in here and I can start adding code to this with no problem, right? It's not going to take me a long time to come up to speed on it. That should be the metric by which the badassery of your code is judged, not by these unrolling loops for performance reasons, or using language specific idioms, or doing some super complicated data structure because it saves you a few CPU cycles. Chances are you don't need that, and it just makes it so much more complicated. And like, you don't need to show off that way.
Yeah. And there are some cases where you do need that. And I would say, if you're that person that needs that, you know it, you know who you are, you know what you're doing.
Yes.
Like, everyone else doesn't.
You're probably writing the compiler.
Right. Cool. So is there anything else we wanted to talk about on optimizing for clarity? I mean, it's just one of those things that I agree with so deeply, but it's kind of a simple concept.
Yeah, I would say too, like, one of the ways that your code is very clear is by the fact that you don't need a lot of comments in it, right? So like, I would say, like, the more comments you have in your code, that's a big smell, a code smell, that your code is not as simple as it is, and it's not as understandable as it should be. So
right.
I think, ideally, you don't have any comments in your code, right? The code should be self-documenting. It should be so elegant and well organized and understandable and maintainable that it just documents itself, that it reads almost as prose. Like, that's the goal, right? Like, that's definitely what I'm shooting for.
Right. Likewise.
Yeah. So, I just can't emphasize that enough. Like, that, if you can just really shoot for that as your goal, as opposed to trying to like prove your badassery in idioms or optimizations or whatnot, like, that's the wrong direction.
Cool. So our last and most important item on the list,
testing. And really what this comes down to is it's accountability, right? So I think, definitely in the past we had organized ourselves as an industry to have, separate teams of developers versus testers versus product managers and whatnot. And now it's kind of become a bit more amorphous and don't typically have separate test teams, but
DevSecOps.
Yes, just throw them all together, right? But still, it's very common though for developers to kind of think like, oh, it's my job to write the code, and like someone else, like whether it be the product manager or customer or something like that, like if they find bugs, they'll tell me and then I'll go and fix them. And instead, it really should be like, you take accountability for the correctness of your software first, right? Like, you really should. You can't call your software done unless it's fully tested, right? So you should have your own, you should obviously unit test or integration test. You should kind of understand like what's the code coverage of this. You should be testing for all the exceptional conditions. What are the unexpected things that could happen? If you're writing backend software, are you not assuming anything like for inputs that are coming in, to the system? So it's just really, it comes down to that, just taking complete accountability for the correctness of your code and having kind of like that mindset that when people do find bugs in your code, like that's a bit of a disappointment, right? Like, it's something that they shouldn't have found because you should have found it yourself.
Mm-hmm. So there's a natural human tendency that I think we have to overcome in order to be able to do this well. And recently I shared with the team an example of this tendency that was on an article. I'll try to find it and post it in the show notes from the New York Times. And I'm going to give it away, unfortunately, so it's not going to be as fun for people that click on it. But basically, it gave you an example. Here's 4 numbers, and they follow a certain pattern. You can test it as many times as you want, and then in the box below, tell us what the rules are. So basically, the 4 numbers they gave were like 1, 2, 4, 8. And then it was like, oh, I get the pattern. It's obviously squares, right? Like let me test a few squares. And so I fully got caught in this. Like I tested a few squares. Oh yeah, totally is squares. Got it. And then I wrote in the box like each number is the square of the one before it. And then I pressed submit, and it was like, you're wrong. The actual rule was that each number is just greater than the number before it. Like you could have written like 1, 3, 17, 100, and that would have also passed the test. And the point it was trying to make is that when I ran each test, the answer was like, yep, that passed. And I was like, yes, of course, because I'm right. I never ran a test that was like, nope, that doesn't pass. I never tested enough to get the no answer. Like if I would have put in, 4, 3, 2, 1, it would have said no. And then I've been like, okay, well, it doesn't like that. And I think that that's what software developers do. And I think all of us do that. We run our code and we're a little nervous that it might be broken in some places, but we know we want to make sure that it works. So we go and make sure that it works. Yep, it works. Good, it works. But of course it doesn't work if you haven't really found out where it doesn't work. There must be some place it doesn't work. So yeah, I think that it's literally a human tendency. Everybody has the same tendency. It is absolutely one that you can overcome. So do it. Overcome it.
Yeah, easy, absolutely. Right? And well, so yeah, we all have bias and
right.
Pattern bias and whatnot. I think the good news here is like that would be an example of black box testing, where just not doing an exhaustive suite of tests versus when you're writing code, you're really doing more white box testing. So
sure.
It becomes a lot easier. You can look at like, okay, what are the inputs to this? Like what are the normal inputs that I'm expecting, and then okay, what are some of the things I'm not expecting? So it becomes you can actually make it a bit more structured, so that even though you do have like pattern bias and whatnot, just by looking at the code and kind of having the advantage of knowing kind of like what this is just a state machine, right? A function, you have a function, it's a set of input, what are the inputs to it? What are the outputs that I'm expecting type thing?
I think with web apps, when I've looked at stuff like where people tend to not test their own code is, let's see what happens if I log out first, if I'm not in the state I expect to be in kind of thing. Or let's see what happens if I go really fast. Mm-hmm. That's something that software developers, I've noticed when they test, they don't like to go fast because they don't want to break anything.
Yeah.
So go fast, try and break things.
Because your users will.
Yes.
Right.
Exactly.
Yeah, absolutely. Yeah. So again, at the end of the day, it just boils down, just take accountability for the correctness of your software. Like don't expect someone else to validate and verify that, yeah, you're complete. Take that responsibility of your own, and you'll be a much better software developer for it.
Right on. Well, that was all 7. So we did practice. We did persistence. We did value understanding above correctness. We did review great code written by others. We did details matter. We did optimize for clarity, and we did testing. Did I get them all?
That's it. It's all 7.
All right. Anything else to add, Chris or Rich, before we wrap it up?
Not for me.
No, and this is just a collection of 7 things that kind of came top of mind to me. It would be interesting to hear like what other people think as well. So any feedback or other ideas on what it is that really makes a great software developer, we'd love to hear it.
Totally agree. And thanks for joining us. We'll talk to you next week.
All right. See you guys.
Later. Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/56. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.